All right, thanks for coming, everyone. I'm going to talk about inequality and taxation. It's a vast subject, and we have pretty much 1 hour, so it's going to be, challenging. And I want to show you both, very simple things to begin with, and I want to show you at the end some very recent research on the topic. It will be subjective, it will be based on my research, but to give you a flavor of what economists are working on today, at least in this field. So suppose that the government has an objective which is to reduce inequality. Okay, the question I want to address in this lecture is how much should it tax high incomes? I'm going to focus on the top incomes, say the top 1% of the income distribution. In this lecture, I will constantly emphasize the importance of connecting economic theory with empirical work. Okay, the essential message is going to be that in order to be able to inform public policy, it is crucial to make models and data interact, and I hope I will be able to convince you of this. I'm going to start by giving you a snapshot of inequality in the US today. So if you look at this table, which is taken from a paper by Piketty, Saez, and Zuckman in 2017, what you find is that the average American adult in 2014 earned $64,000 of income. Okay, this includes all types of income, labor income, capital income, etc. Now this number, this average income of Americans, masks a lot of variation, a lot of heterogeneity. So if you focus on the rich, on the poorest 20% of Americans, so 1 American out of 5, their average pre-tax income, before taxes and transfers, is closer to $5,000 for 1 year. Okay, on the other end of the spectrum, if you look at the top 1%, the richest 1%, before tax, their income on average is $1.3 million. So there is a large amount of heterogeneity and inequality in the US today. So of course the government does some redistributions through taxes and transfers. And if you look at the post-tax income distribution, the inequality is less marked. Okay, the tax code is progressive overall, but there is still a large amount of heterogeneity. Okay, so that's the first thing I want to show you. The second thing I want to show you is the evolution of the tax rates on top incomes over the century. In the US, the progressive income tax was created in 1913, okay, with very low tax rates. And the tax rates on the top incomes were raised to very, very high amounts. First during World War I, okay, to finance the involvement of the US in the war. And then during World War II, during the 30s and World War II, so that throughout the 1950s, the tax rate on top incomes in the US was above 90%. It's confiscatory tax rates. Okay. Then Kennedy, John Fitzgerald Kennedy, and then Ronald Reagan drastically reduced the tax rate on top incomes down to below 30% in the 80s. And today, the tax rate on top incomes in the US is about 40%. And it concerns incomes that are above $400,000 a year. Okay, so that's roughly the top 1%, the richest 1% Americans. So the first thing I want to emphasize, that's the one thing you need to remember from this lecture, is that some of you may be surprised to see that the top tax rate was above 90%. This does not mean that these Americans paid more than 90% of their income in taxes. Okay, this is a marginal tax rate. So that's the first thing I want to emphasize, the difference between a marginal tax rate, which applies only to the fraction of your income that's above a certain threshold, so currently above $400,000. Only on that fraction of your income, you pay these high tax rates. But on the fraction of your income that's below $400,000, you pay the tax rates that poorer people pay. Okay, so this is a marginal tax rate. And if you look at the average tax rate, so how much Americans actually pay in taxes, even in the 50s, this is including all taxes, federal, state, local, sales tax, etc. It never went beyond 45% for the top 1%. Okay, so keep in mind the difference between marginal tax rate, which applies only if you're in the top bracket. This is what you're going to pay on the additional dollar you're going to earn. The difference between that and the average tax rate, which is which fraction of your income you're going to spend and you're going to send to tax authorities. Okay. So this doesn't work anymore. I see. Okay, so I'm going to show you 4 things today, if time permits. first, I'm going to show you some very simple graphs that are going to show you the evolution of inequality in the US over the century. Okay, so these, for many of you, if you've read the books by Thomas Piketty and the papers by him and his co-authors, you're probably familiar with these graphs. I want to go back to them and explain to you briefly what happened over the course of the century. And then in the second part, I will use those numbers. I will show you how to use this data to inform public policy. I will show you the theory of optimal taxation and how it uses this empirical work to figure out what should be the optimal tax rate on top incomes. Okay? Then I'll go back in a third part. I'll go to I'll try to understand the deeper reasons why. I'll show you that inequality has increased over the past few decades. So we're going to try to understand why, and we're going to emphasize the role of technological change in the evolution of inequality. And in the fourth part, I will go back to theory. Okay, so it's going to be data theory. Go back to theory and show you how to integrate these notions of technological change, etc., in a model of optimal taxation to again refine the understanding of the optimal top tax rate. So let me start by talking about the evolution of inequality over the century. The way I'm going to measure inequality is by talking about top income shares. So what's the share of income of, say, the top 1%? If you take the richest 1% Americans, how much of the total income of the economy do they capture? Okay, so if there is perfect equality, they're going to capture exactly 1%. If there is inequality, they're going to capture more than 1%. So the construction of such a series of income shares dates back to Kuznets in the 1950s and has been revived by Piketty, like I've said before, and his co-authors about 20 years ago. And it's something that's still very active. They are still updating those series every year, and they are doing it for more and more countries in the world. So I want to focus on the US in this lecture. They use tax data. So since the creation of the income tax, the tax authorities in the US have compiled tables of statistics, giving them for a large number of income brackets the number of tax returns, the amount of income that is reported on the tax returns, the composition of that income between business income, labor income, rents, royalties, etc., etc. So you have very detailed information about the income and its composition for those people who file a tax return. Okay. So let me show you, before I talk about caveats, let me show you what this series looks like. So this is the top 10% share in the US over the century. So this is how much of the total national income accrues to the top 10%. Okay, so what you find, and that's striking, and you must have heard that if you followed the debate on inequality those past few years, that has followed the U-shape over the century. The top 10% share was very high up to the 1920s, okay, around 45%. Then it drastically dropped. Inequality remained at a low, point between the 50s and the 70s. During 20 years, the top 10% share had dropped down to 32 or 3%. And since the 80s, it has started bouncing back, and it's now reaching levels that are even higher than those they were at the beginning of the century. So this is enormous fluctuations in the share of income captured by the top 10%. I just want to mention three caveats. When you see such series, you're going to see many of them if you work on inequality, three issues with them. The first is that it's only about pre-tax income. Okay, it's only about the gross income. So it doesn't take into account the taxes you pay and the transfers you receive. So to the extent that the government operates some redistribution from the rich to the poor, the inequality based on disposable income may be less striking than inequality based on gross income. Okay? So that's the first caveat. The second caveat is that the tax unit in the US is the household. So this does not, so to the extent that gender inequality across spouses has evolved over the century, this is also going to lead to biased series. And the third caveat is that it's only about the income that is reported on the tax returns. So it ignores a lot of types of income. There is a lot of income, in particular capital income, that is tax exempt, that is not part of this series. And it also ignores tax evasion, of course. So people are trying to refine, today there was an article coming out literally 2 hours ago by Gabriel Zuckman, who's working in this field, where he tries to take into account the evolution of of tax evasion to refine the series, including for those kind of income that are unobservable on tax returns. But so these caveats in mind, what this is telling you is that inequality was very high up to the 1920s. It then dropped and stayed low for 20 years, and then bounced back and is now back at very high levels. So what I'm going to do now is I'm going to decompose the top 10% income share into 3 groups. The top 1%, which is in black here, and the next fractile, so that's the top 5 to 1%, and that's the top 10 to 5%. And what this series is telling you is that these enormous fluctuations in the top income shares are really driven by the top 1%. Okay, the top 2 to 10%, they have increased over the past 50 years, but they have increased at a much more steady and slow rate. The enormous fluctuation, the U-shaped, really comes from the 1%. So to give you a sense of what's happening, very superficially, there are entire papers and books written about this. Let me briefly give you the history of what happens. So what you can show is that the drop in the top 1% income share is almost entirely due, at the beginning of the century, is almost entirely due to top capital incomes. It's a drastic reduction in top capital incomes. I have here the splits in capital versus labor income in this top tax series. The labor income of those individuals has remained pretty flat, but it's really the capital income share that has followed the large decline. And that's due to the Great Depression that destroyed a lot of businesses. That's due to the post-World War I depression. So a bunch of macroeconomic shocks occurring in the first half of the century that have destroyed businesses. A lot of fiscal shocks also. So the corporate tax rate was increasing and steeply progressive at that time. So that has mechanically reduced the distribution of dividends to the stockholders. So there is a very large decline in the top capital incomes, in the concentration of capital income at the top over the first half of the century. Then so the second sub-period is this plateau here where inequality was pretty flat. So again, the top 1% income share went from almost 25% to less than 10%. So it's an enormous decline, a 3 times decline. And so we'll go back later on in the third part of this lecture about why this income share has remained low and why it has started bouncing back afterwards. One idea that we can think of is I showed you the pattern of marginal tax rates at that time. There was a very progressive income tax system, but not only for income taxes, but also for corporate taxes and estate taxes that possibly have kept inequality relatively low. We'll go back to the role of technology in this afterwards. The third sub-period is from 1980 to 2000, where basically going back to the split between labor and capital incomes, there was a huge surge in top labor incomes, okay, from 1980 to 2000. And that's coming from, the top CEO pay that has drastically increased with the generalization of stock options in particular. So you have basically moved from a world that was composed of rentiers of very high top capital incomes to a world of working rich, which derive most of their income or a large part of their income from wages and salaries. Now, sorry, I have trouble with the slides. The last part is what happened since 2000. It turns out that this story of the working rich is actually not that true anymore. The top wage incomes have become relatively flat since 2000, and the top capital incomes have started increasing again. So now we're going back to a society with enormous wealth inequality and very concentrated capital income. So that's a very superficial bird's eye view of the evolution of inequality, of income inequality over the century. One thing which is going to be very useful, a very useful summary measure of all of this inequality is what we call the Pareto Coefficient. So if you look at the US, for example, or any other country or any time period, what you find is that, say, take someone who earns $500,000 a year, and you look at everyone who earns more than $500,000 a year. So everyone who is above that income threshold. Well, the average income among those people is approximately twice $500,000. So the average income above 500 is about 1 million. And the average income above $1 million is about $2 million. And the average income above $2 million is about $4 million. Okay, so the factor 2 here may be varying over time. That's, there is more inequality when the factor is higher, when the average income above $500 is no longer 1 million, but 1.5 million. But still, the ratio between the average income above a given income threshold and that threshold is remarkably constant, for the top 1%. Okay, so that's what we call the Pareto Parameter. This is an empirical regularity that has been found by Pareto more than a century ago. It's something that is very well known and very striking that we're going to use later on in our theory of optimal taxation. Okay, so now basically I've told you that this Pareto parameter was about 2. It's now that his inequality has increased, it's more like 3. So the average income about $1 million is more like $3 million. And so that gives you an empirical, a summary measure of inequality. Okay? So let's try to use this data to find out what is the optimal, in a sense that I will define, tax rates on top incomes. So I'm going to do a bit of math. So what we're going to have is a population composed of individuals. There's going to be a continuum of individuals, and they are going to be indexed by theta. Theta is going to be their skill, is going to be their, think of their education, think of their productive ability in general. An individual who has skill theta, so the higher the theta, the more productive you are, is going to choose a labor supply, L of theta, so he's going to choose how much to work, okay? And he's going to earn a pre-tax income, which is going to be the product of that productive ability and that labor supply, okay? So that's going to be his or her income. Okay, so the more productive you are, the more a unit of labor effort is going to translate into a unit of income. And that individual is going to pay a tax to the government, which is a function T of his income. Okay, so it's really important that the tax is an income tax here. So the key here in this model is that labor supply, how much effort an individual is going to exert, is going to depend on the tax rates. And we're going to describe how. So the individual is going to maximize a utility function, and his utility is going to be given by his disposable income, his consumption, if you prefer, how much he works, how much he earns, minus the tax he pays on that income. So that's his consumption, minus the disutility of effort. Okay, so the more effort you exert, the lower your utility. And that this utility of effort is going to be convex. Okay, I'm going to talk about what epsilon is in a minute here, the exponent. Okay, so you want on the one hand, you want to work hard because you want to increase your consumption. On the other hand, you don't want to work hard because that requires putting a lot of labor effort, which is costly. Okay, so that's what individuals do in this very simple version of the model. What does the government do in this model? The government is going to maximize social welfare. So what is social welfare? Social welfare is going to be a sum of individual utilities. He's going to take the utility, the welfare of every one of the agents in the economy, and he's going to weight them and add them up. Okay? So he's going to take the utility of each agent, so again, indexed by theta, by their skill, and there's going to be what we call a social welfare function, which is going to be concave, which is how much does the utility of a given agent matter for social welfare. So the higher the utility of any agent theta, the higher the social welfare. But since this social welfare function is concave, if someone already has really, really high utility, it's not going to be very useful to give them even more consumption or even more income because it's going to increase social welfare in a concave way. All right? So it's the same intuition as the decreasing marginal utility in standard models. Here there's decreasing social marginal utility if you want. So the government is going to maximize this sum of individual utilities subject to a budget constraints. Government cannot spend more than it receives in taxes. So the sum of all of the taxes and transfers, the taxes the government receives minus the transfers that the government gets, is going to have to be positive. Okay? So that's basically a problem that has been written by Merlis in 1971. Merlis got the Nobel Prize in the 90s. that he solved. It's a simple version of it, but it highlights the two key forces in the determination of the optimal income tax rate. On the one hand, you want to tax a lot and redistribute a lot because the social welfare function is concave. Remember, if there was nothing else in the economy, you would like to equalize all of the individual's utilities, because taking money from someone who has a very small marginal utility and giving it to someone who has a very high marginal utility is going to be beneficial. So at the end of the day, you want to equalize marginal utilities, and therefore you want to equalize the amount of consumption people get. Now the problem is that if you tax, what we're going to see in a second is that if you tax people, and if you want to really equalize people's disposable incomes, you run into incentives problems. Recall that the labor supply of the agents is going to be endogenous to taxes, and so you don't want them to work too much less if you tax them a little bit more. Okay, so there's a trade-off here between the size of the pie. Okay, if you tax them more, they are going to work less, to put it simply, and the distribution of the pie, which you would like to make relatively equal by taxing and redistributing. So it's a trade-off between equity and efficiency. Let's talk about the efficiency part of this first, the size of the pie. How does a higher tax rate reduce the size of the economic pie? How much less people work when you tax them a bit more? So I'm not going to solve this problem in its entire generality. It's too complicated for this lecture. What I'm going to focus on is the optimal top tax rate, the tax rate on the high incomes. So if you're a high income, Y is larger than a threshold Y bar, say $400,000, you're in the top tax bracket. The total tax you pay is the tax that anyone who has income Y bar pays. Okay, remember the definition of the average income, average tax, is the tax that everyone with income Y bar pays, plus a fraction tau, that's the marginal tax rate, the tax rate on top incomes that I showed you before. A fraction tau, say 40% of the income above that threshold, okay, of the income you earn above $400,000. Y, your income, minus this threshold Y bar. So the tax you're going to pay is going to be, you know, on these additional dollars above Y bar is just going to be a constant fraction of your income. And that's this parameter tau that we want to focus on today. What's the optimal value of that parameter tau, the one that trades off efficiency and equity? So the key thing, so if you solve the individual's problem, it's very simple to solve, the one I've showed you before. What you find is that the individual income choice, the choice of income or the choice of labor supply, is going to be decreasing in the marginal tax rate tau. Okay, so when you tax people at a higher rate, they are going to work less. That's basically the efficiency part of the equity efficiency trade-off. And so the key for incentives, you can show that the percentage change in individual's income or labor supply when the tax rate changes by 1% is given by this parameter epsilon, which I've left free for now, which we call the elasticity of labor supply with respect to the marginal tax rate. It tells you how much less people work or earn when you tax them a little more. Okay? And that's going to be the key parameter that's going to determine the size of the economic pie when you tax a bit more. So that's the efficiency. Now for the equity, what do taxes do on individual welfare? Well, what you can show, again, very simply in this model is that utility here increases or decreases 1-for-1 with the taxes, with the total tax that you pay. Okay, so if you pay a bit, higher tax, a higher total tax, average tax rate, that's going to make you poorer and hence less well off. Okay, and your utility is going to move 1-for-1 with this total tax bill. Okay, so the two terms of the trade-off are going to be this elasticity of labor supply and this effects of taxes on welfare. So now, given that, it's very simple, in fact, to derive the optimal top tax rate. So what we're going to do to find the optimal tau, we're going to increase this tax rate. Imagine a thought experiment where the government increases the tax rate tau by 1 percentage point. Okay, so that's going to bring revenue. People are going to pay more taxes. And rebates all the revenue it gets, lump sum in a uniform way to everyone in the population. It just increases the transfer that it gives to everyone. Okay, so you raise the marginal tax rate at the top and you rebate to everyone in the population. So let's first compute the size of the rebate. So how much are you going to be able to rebate is how much revenue you're going to have from the increase in the marginal tax rate at the top. So it's just accounting at this point. First, mechanically, everyone whose income is above that threshold Y bar in the top tax bracket is going to pay an additional amount of taxes given by this 1 percentage point increase in the tax rate times the difference between their income and the threshold of the bracket. Okay, so that's exactly how much more, if they did not change their labor supply, that would be how much more they would pay in taxes mechanically. Okay, so if the tax rate goes from 40 to 41%, they will pay 1% times their income above 400,000. So that's the mechanical effect. Now the behavioral effects of the tax change on government revenue. Remember that people are going to work less and hence earn less. By how much? Well, if you change their tax rate by 1 percentage point, that's going to reduce their labor supply by an amount given by the elasticity of labor supply, almost by construction, almost tautologically. They are going to work less by epsilon times this change in the tax rate. And the loss for the government is going to be the marginal tax rate times this change in income of the individual, okay? Because on each dollar of income that individuals stop earning, the government loses the marginal tax rates on that income. So, okay, 40%. So that's the total revenue from the increase in the tax rate by 1 percentage point. So that's the total rebate. So now, when you compute the impact of this tax reform, raising the marginal tax rate above an income threshold by 1% and redistributing lump sum, you can compute how much more taxes and transfers people pay or get. Well, everyone gets the rebate, R, which I've just characterized. And only those whose income is above the income threshold Y bar, the top tax bracket, are going to pay, in addition, again, like I said before, Y minus Y bar, their income above that threshold, times 1 percentage point. So that's in the square bracket here, that's how much every individual in the economy, depending on where they are in the income distribution, is going to pay or get in transfers or taxes with this thought experiment. Okay, this is just accounting at this point. Now, how does that increase social welfare? So you redistribute income in this way by raising the tax rate and rebating. How does that change social welfare? Well, this change, remember that I told you that the utility of agents changes 1 for 1 with this change in disposable income that they have, hence the change in the tax that they pay. And in terms of social welfare, to get the change in social welfare, you multiply this change in consumption that each one has by what we call the marginal social welfare rate, which is the marginal utility, the marginal social utility, remember the concave social welfare function G, the marginal social utility of giving an additional dollar of consumption to the individual with that income level. Okay? So at the optimum tax code, at the optimum tax rates, this tax reform of increasing the tax rate and rebating must have no effect on social welfare. Because if it did, there would be a reform that would make social welfare larger. There would be a budget neutral reform that would make social welfare larger. So if, for example, this reform brought a positive amount of social welfare, then that tax rate could not be optimal. Okay, so the optimal tax rate is the one that makes this sum of individual changes in utilities equal to 0. You can solve it by hand, it's 2 lines of algebra, and you get that the optimal top tax rate depends on 3 things, 3 variables. The first is this G here. G here, like I said before, it's how much the government values the welfare of those individuals above the income bracket, in the top income bracket, above the income threshold Y bar. How much, if you give them $1 additional, how is that going to change the social welfare? Okay, so presumably by little, because if it's the top incomes and the social welfare function is concave, giving them an additional dollar of consumption is going to be very small. So we're going to take this G, the redistributive taste of the government towards the top, to be 0. Okay, it doesn't care about giving money to the top. It just wants to extract revenue from them. The second parameter it depends on is this epsilon, this elasticity of labor supply, which counts how much less people work when you tax them by 1% more. Okay, so that's the key parameter. I'm going to go back to that earlier. Imagine, so I'm going to pick a number that's sort of within the ballpark of the empirical estimates, let's say 0.5. And the third variable on which the top tax rate, the optimal top tax rate depends, is the Pareto parameter that I've talked about earlier, which is a summary measure of inequality, which is the ratio of the average income above a threshold by that threshold, which remember is a constant approximately equal to 2 or 3 in the US. So what that tells you almost immediately is that the optimal top tax rate, if you take, you don't want to redistribute money towards the top, you have a Pareto parameter of 2, and you have a labor supply elasticity of 0.5, that immediately tells you the optimal top tax rate is 50%. Okay? Now, if inequality has increased like it has in the recent decades, now the Pareto parameter, like I said before, is more like 3, right? The average income above $1 million is more like $3 million. So that's an increase in inequality. You plug it in your optimal tax formula here, you get 57%. So you can see very easily how the optimal top tax rate depends on inequality. Now, this is an uncontroversial number, okay? This Pareto parameter is a number that you observe in reality. What is much more controversial is the value of this labor supply elasticity. Concretely, how much less people work or how much less people earn when you tax them a little more. And there is a huge, so the good news is there is a huge empirical literature about it, like really huge. The bad news is that people still disagree about it. The estimates in the literature vary between epsilon close to 0. Basically, you can tax people more. They are not going to change their behavior much. They are not going to earn less. They are not going to evade their taxes or not going to work less. To much larger elasticities. Elasticities that are above 1. So when you tax them 1% more, they are going to work 1% less, which is it's more like the right-wing view, which tells you that because there is such strong disincentive effects of taxing people, you want to tax, from this formula, that I can get to, you want to tax people much less if the elasticity is weak. So how do we, in practice, estimate this elasticity? It's really the crucial parameter to estimate what should be the optimal top tax rate. So let me show you one graph, which you should recognize. It's the combination of the graph I had shown you for the top marginal tax rate in the US over the century. Remember, it was above 90% in the 50s. Now it's more like 40%. And I superimpose the graph of the top 1% income share that I've shown you before, which went from about 20% to 8% to now back to 20%. Okay, what's clear from this graph at first sight is that there is a strong correlation between those two. So it does seem to be the case that when you raise the tax rates at the top, the income share of those individuals at the top is lower. And when you lower the tax rates, their income share rises. So from this, by dividing one curve by the other, you can basically get the effect, assuming that the effect is causal. So assuming that it's because the tax rates have been decreased that the income shares have increased, you can get the implied elasticity, epsilon, that we want, how much less people earn when you tax them a little more, and what you're going to get if you do that here is epsilon equals 0.5 approximately. Now to give you a sense of why this is very controversial, is that here what I've been assuming is that the entire surge in top income shares is due to the drop in the marginal tax rates. Okay, there may be a reverse causality, for example. It may be because the income share has surged that because of much more concentration of income at the top, that the top 1% has been able to influence, or lobby politicians to reduce the top tax rates. So it can be a reverse causality, which obviously would have very different welfare implications. So obviously, the wage of people who graduated from college is on average higher than the wage of those who did not go to college. And what you find is that the evolution of this relative wage over the past 60 or so years, so first has started increasing, then there was a decline, okay, a decline in the 60s, 70s, and it has bounced back starting in the 80s. So that seems to be, this increase in inequality that I was talking about is reflected here in this college to high school wage premium. Okay, so if at the same time you look, again, this is for the US, if at the same time you look at the number of people who went to college and who went to high school, it turns out that there has been a massive increase in the number of people going to college. Okay, in particular with an acceleration in the 1960s, 1970s, which corresponds to the Vietnam War. So the Vietnam War, because you could defer going to Vietnam if you stayed in college, a lot of people started going to college. And there has been a deceleration after the 80s, so after the end of the Vietnam War, After the end of the baby boom generation as well, these people were already past their college years. And also because, of course, like I said, the college premium had decreased. But so the curious fact here is that despite this enormous increase in the number of people going to college, in the relative number of people going to college, there has been this enormous increase in their returns. Okay, when you think about supply and demand, you think that when there is more supply, the price should go down. Okay, here, despite there being much more supply, the returns to going to college has even increased. So going back to the supply and demand explanation, it has to come from the demand. Right? It has to be that the demand, and think of it as technology, has enormously increased. The demand for high-skilled labor, for college-educated workers, must have drastically increased since the 80s. So let's put some formalism on this. Like I said, so there is a large increase in the relative supply of skills of college-educated workers, yet no decline in the skill premium, in the relative wage of skilled workers to non-skilled workers. So the demand for skill must have increased. What is this demand? So that's what we call skill-biased technological change. So it's this idea that technology is complementary to skilled workers. So there must have been some change in the technology that made the high-skilled workers more productive. And so much more productive that it even more than compensated for the increase in the number of people going to college. Okay? So to put some formalism about this, very simply, imagine that you have a production function with two inputs. So you're used to labor and capital that are complementary in production. Here, we think of low-skilled workers, say high school graduates, and high-skilled workers, say college graduates. And the key is that these high and low skills are imperfect substitutes in production. So when there is a higher supply of high-skilled workers, okay, this is going to raise production, but this is going to depress their wage, and this is going to raise the wage of the input that's complementary, meaning low-skilled workers. Similarly, when there are more low-skilled workers in the economy, it's going to depress their wage, but it's going to raise the wage of the complementary input, which is high-skilled workers. Okay, so that's just like the Cobb-Douglas production function that you're used to in macro. The key here is that these inputs, number of high-skilled workers and number of low-skilled workers, are multiplied by theta H and theta L, which is the return to the skill. It's the technology. So it's technology that we call factor augmenting. So what that does here is that when the technology term associated with the high-skilled workers, theta H, becomes higher, it's going to raise the wage of high-skilled workers because it's going to be this technology is going to be complementary with the high-skilled workers. Okay, so it's going to raise their productivity. And so what you get here is that when the relative supply of skills, the relative number of high-skilled to low-skilled worker increases, that's going to lower the relative wage of the high-skilled workers. Okay, more supply reduces the wage, more supply of skills reduces their wage, by an amount which we call sigma, which we call the elasticity of substitution between the two inputs. How substitutable or how complementary are the two inputs in production? Inversely, when the relative technology of the high-skilled to low-skilled workers increases, that's going to raise the relative wage of the high-skilled to low-skilled workers. Hence the term race between education and technology, because at the same time, education has increased. Okay, so that should have depressed the relative wage of the high-skilled workers. So it has to be almost, again, tautologically, it has to be that the demand has increased, the demand for high-skilled workers has increased, so the technology has become more complementary to skills. Okay, and the key parameter here, I didn't write all the math, but the key parameter here is going to be this sigma, which is how complementary are the two inputs in production. And so therefore, how much is a relative increase in the supply of skill, how much is that going to depress everything else equal, their relative wage? Again, sigma is a parameter we can estimate in the data. So I'm going to show you a graph here. So that very simple model, again, it's extremely simple, but it goes a long way in explaining. Okay, it goes a long way in explaining the evolution of the wage premium and hence inequality over the course of the century. So, of course, you don't really observe technology. You don't really observe how complementary technology is with high-skilled or low-skilled workers. So we're just going to assume that it grows at a constant rate over time. Okay, so technology is just going to be skill biased in the sense that theta H, the technology that's complementary to high-skilled workers, is going to grow faster than the technology that's complementary to low-skilled workers, and it's going to grow at a constant rate. This ratio is going to grow at a constant rate. Now, what you do observe is the relative supply of skilled workers. Remember the Vietnam War, there was a lot of people staying in college, and then less so. So that you can plot, and you can use that equation. So you can use that equation to plug in the numbers you observe here for the number of high-skilled to low-skilled workers. Assume a constant rate of increase of this technology ratio here, and that's gonna get you the evolution of the skill premium, of the wage premium, and you can compare that to the data. And when you do that, you see that you can get actually very close. So just by varying the relative supply of skills, the way you observe it in the data, which is due to exogenous factors, you know, the Vietnam War and all this kind of stuff, just by varying that, you can observe, assuming a constant rate of skill bias in the technology, you can see that you can replicate pretty closely the evolution of the wage premium, the decrease in inequality in the 60s, 70s, and then the increase after the end of the Vietnam War in the 80s and 90s. And so if you remove the trend in this series, it's easier to see. So in black here is the change in the wage, and in gray here is the change in the relative supply, the number of skilled to non-skilled workers. So again, relative to the trend. So when you see that there is a fast increase in the number of high-skilled workers, in the number of college graduates, there is a corresponding decrease in the relative wage. So these are data, assuming a constant rate of increase in technology. And vice versa, so that the movements in the wage premium track very closely the movements, in fact, in just the supply of skilled workers to unskilled workers. So it's a race between education and technology in the sense that if the supply of college graduates increases faster than the skill bias in the technology, which is assumed to be constant rates, then the wage premium decreases. And if the supply of high-skilled workers increases less fast, so after the end of the Vietnam War, then you have an increase in the wage premium because technology increases faster than the relative supply of skills. So this model is very simple, but it goes a long way in explaining the movements of inequality over the past 50 years. So the problem of this explanation, I mean the exciting thing about it as well, is that in the Merlis model I've shown you before, in the model where we derived the optimal top tax rates, this was a partial equilibrium model. This was a model where the wages of different agents were fixed. There was no such general equilibrium effect. There was no complementarity between skills in production. So if there was an additional supply of very high-skilled workers, that would have absolutely no effect, neither on their wage nor on the wage of the low-skilled workers. Okay? So what we need to do to understand the impact of technological change for optimal taxation, we need to extend the model I've shown you before to the general equilibrium. And that's something that's only been done very recently. So Stiglitz has an important contribution in the 80s, but a very limited scope. And it's been generalized much, much more recently, meaning like the past 3 or 4 years, to the general equilibrium model. So I don't want to go into math. I want to just try to make you understand what are those general equilibrium effects. So recall that in the partial equilibrium model I've shown you before, there were two key things. There were incentives and welfare. On the one hand, taxing people was bad for incentives. You make them work less. And on the other hand, it was good for welfare because you can redistribute income. Okay, so what we saw is that if you increase the marginal tax rate of agents, it's going to make them work less. That was about the marginal tax rate. And if you increase the total or average tax rate of the agents, it's going to make them poorer and hence worse off. Okay? But there was no role for the marginal tax rate in welfare in particular. It was all about, I said to you, the tax bill and utility move one for one together. Now in general equilibrium, now that you have a production function with all these skills in the economy that takes as inputs all of these skills in the economy, you have a lot more things going on because wages adjust. Okay, so the first thing you have is that if you increase the marginal tax rate of someone, again, they are going to work less. But that's not the end of the story, because if they work less, like I've said before in general equilibrium, that's going to raise their wage. And that's going to tend to lower the wage of those inputs that are complementary in production. Okay? So the marginal tax rate here will have further effects on incentives through the wages, through the pre-tax wage distribution, compared to the partial equilibrium model where wages were fixed. And the only response was through labor supply. So both because of decreasing marginal product of labor, if I work more, I earn less, and through the skill complementarities, if I work more, you earn more. Okay? Now, it's not the end of the story, because if you know, my tax rate increases, I work less, that reduces your wage, you guys are going to work less, okay? Because the return to working is lower. So if you work less, it will have feedback effects on everyone else's wages in the economy, etc., etc. So you have an infinite sequence of general equilibrium effects here that seems to be a bit difficult to make sense of. So that's the first thing. So the effects in this general equilibrium model, the effects of taxes on incentives are much more subtle or complicated than in the model I've shown you before. The effects on welfare, again, before the utility of an agent responded 1-for-1 with their total tax bill. Here it's also no longer the case. Here, even conditional on a total tax bill, the marginal tax rate is going to matter. Why? Because if I increase your marginal tax rate, you're going to work less and you're going to earn more, pretty much. So that's going to make you better off. Okay? So in general equilibrium, because of this decreasing marginal product of labor and skill complementarities, even conditional on a total tax bill, what's your marginal tax rate is going to matter for your welfare. And the sort of counterintuitive thing, perhaps, is that higher marginal tax rates, by making you work less and earn more, are going to make you better off. Okay? So what you can do, you can nevertheless find an optimal tax formula. I'm not going to derive it, it's a bit more complicated. But you obtain a modified optimal tax rate formula compared to the previous case. Remember before, the optimal tax rate I showed you before, there was this G, which was how much you care about redistributing to the top, to the rich. We set it to 0. And there were two terms here. There was the Pareto parameters of the income distribution, which is equal to 2 or equal to 3. And there was the elasticity of labor supply. How much less people work, so the incentives. How much less people work when you tax them a bit more. So here, the first thing that happens is that the elasticity of labor supply compared to the previous formula is going to be dampened, because if I tax you more, you're going to work less, okay? But that's going to raise your wage, so that's going to make you work a bit more. Okay, so the relevant elasticity that you care about is dampened compared to the one we had used before. And if the elasticity is smaller, it means that the disincentive effects of taxes are smaller, and you want to raise taxes, everything else equal. The second thing is that there is a psi term here, which was new, which is not there in the previous formula, which is coming from the fact that if I raise your marginal tax rate, you're going to work less, but that's going to lower the wages of everyone else. So everyone else is going to work less. Okay, so if I raise the marginal tax rate on someone, that's going to have a negative externality on everyone else. Okay, and everything else equals, you can show that that's going to tend to lower the optimal marginal tax rate. Okay? At least if you care less about those people relative to the average individual in the economy, which is the case here, we assume, at the top. So the optimal top tax rate formula here is modified compared to the previous one. And of course, this psi parameter, which is the negative externality you have by working less on everyone else, depends on this elasticity of substitution, sigma, that we've seen earlier. Okay? So if you assume that sigma, the elasticity of substitution, is about 1.5, and everything else is as before, the Pareto parameter of 2, the elasticity of labor supply is 0.5. The optimal top tax rate before was 50%, now it's 40%. Okay, so you have this sort of trickle-down externalities that tend to make you want to reduce the optimal top tax rate. That depends on this elasticity of substitution between people. Okay, and from then on, you can evaluate the effects of technical change on the optimum tax rate. Okay, you can say you can estimate your model. You can estimate in particular the elasticities of substitution between agents, between skills, before technical change and after technical change. And once you've done that, you just plug it in your optimal tax formula, and you get a new recommendation for an optimal tax rate. Okay, so that's what the recent paper by Alice Cornas and Sleet does, and they find how the optimal tax policy should be modified. I want to talk to you about, the last thing I want to talk to you about is, instead of doing that, so that's a paper I've been working on last year, So instead of doing that, instead of recomputing optimal tax policy after technical change has happened, what you can do is you can say, let's try to implement a tax reform, starting from the actual tax code, the US tax code, say. Let's try to implement a tax reform that's going to offset the welfare losses of those who have lost from, say, technical change by redistributing the gains of the winners. Okay, so you're going to tax, intuitively you're going to tax those who have gained from technical change, and you're going to redistribute to those who have lost. So first, what does this tax reform look like? And two, is it budget feasible? Is it feasible for the government, or how much does it cost on government revenue? Okay, so it's so that's what we call, it's a very old problem in economics that was set up by Hicks in the 1930s, Hicks and Kaldor. It's called the compensation principle, but here we do it in a model where you have this continuum of skills with nonlinear tax rates as well as distortionary taxes. So this problem is difficult. Why? Because one thing you can do is, well, let's try to increase the tax on the rich, say who have won from technical change, and redistribute to the poor. But if you want to increase the taxes on the rich, you're going to have to raise their marginal tax rates. And like we said before, the marginal tax rate will in turn induce welfare effects because it's going to affect the wage distribution that will themselves have to be compensated using the tax code. Okay, so it's actually a difficult problem, but it has a tractable solution. And what you find here if you do that is that if someone loses from a change in the economy, say technical change, you will want to lower their taxes like you expect, but you want to lower the taxes of everyone who earns a lower income than them in a progressive way. And this rate of progressivity of the tax reform will offset everyone's gains and losses from the technical change is going to depend on the elasticity of substitution between skills and depend on the elasticity of labor supply. Okay, so this is just very superficial view of what economists today, it's at least one economist today works on. It's just to give you a flavor of what kind of questions are being asked today. So I just want to conclude here and talk about both the field of research and how it's represented in Toulouse. So the field of research is an extremely exciting field. It's the theory of optimal taxation is both very theoretical, if you want it to be theoretical. Like we said, you have to find optimal taxes in sophisticated environments. You can think of more sophisticated environments, like dynamic environments, where you want to think about optimal capital taxes, etc., etc. And it's also very empirical-minded. Okay, it's all of the variables we are talking about fundamentally are objects that are observable in the data and that can inform our model. So here it's really the interaction between empirical work and theoretical work that's key in informing the public debate. So this field of public economics has a very strong tradition, in fact, at TSE. So Jean-Jacques Lafont was a pioneer in the field. And today you have people like Jean-Marie Lozakmer, Helmut Kremer, who work on this and who have made very important contributions on this field. You have people working empirically in these topics. Tim Lee in particular, or Mohamed Saleh, or Nicolas Pistolesi are people who are very familiar with the empirical aspects of what I've been talking about. And most importantly, perhaps, this field of taxation is part or uses the same techniques as a broader field which is called contract theory, for which TSE is one of the very best departments in the world. So all of these people, Tirole, Kremer, Julien, Ray, Mariotti, Gomez-Garrett, I probably have forgotten some of them, are people who are, who were and who are at the forefront of this field. There are also some very promising graduate students who are currently working under our supervision on this. And if it gives you an interest in working on these questions, feel free to ask me or the other people for some insights. Thank you very much for coming here.